Could you build an iPhone in the Stone Age? I mean, it sounds completely ridiculous, right? You've got no factories, no clean rooms, definitely no electricity. But what if all the essential parts were just, lying around, waiting to be found? Let's dive into a little story of how, just maybe, it could have happened. It's a fun question to think about, isn't it? Could one of our distant ancestors, someone we might call a caveman, actually stumble upon the secret to, well, all of modern electronics? The transistor? It seems absolutely impossible. Or is it? Because here's the really wild thing. The fundamental building blocks, we're talking copper, silicon from sand, all sorts of minerals, they've been in the Earth's crust forever. So let's just imagine a story. Let's play a what-if game about a prehistoric inventor who, without even knowing it, takes the very first steps into the electronic age. So meet Grok. Grok is a clever guy, for sure, but he has a big, big problem. See, he's the lookout for his clan, but his voice, it just isn't very loud. So when a saber-toothed tiger is creeping up, his big warning shout is more of a warning whisper. He needs to find a way to make his small voice big. Grok's big quest for a louder voice, it begins not with sound, but with a flash of light. He's about to discover the most basic concept in all of electronics, something we now call a circuit. Okay, picture this. One stormy night, lightning cracks across the sky and hits a nearby ridge. Grok sees the bolt slam into the shiny greenish rock, what we'd call copper ore, and the energy seems to travel right along it, making the whole thing glow. But the dry log sitting right next to it? Nothing. The lightning spirit, as he might call it, doesn't touch it. He has just seen the difference between a conductor and an insulator. So Grok starts messing around. He figures out that if he makes a continuous, unbroken loop with this copper rock, the energy, maybe from another lightning strike or maybe just some static from rubbing animal fur, it seems to flow around and around in a circle. He scratches a picture of his loop on the cave wall, and what's absolutely amazing is that his primitive little drawing looks surprisingly like a basic circuit schematic we use today. So the most important thing Grok just figured out is that a circuit has to be a complete, unbroken loop. Think about it like a hula hoop that's filled with marbles. If you push one marble, they all have to move, right? Because there's no beginning and no end. But what happens if you break the hoop? The marbles stop. The flow is gone. Any break, anywhere in the loop, stops the whole show. All right, so Grok can make energy flow now, but he can't really control it. It just goes. His next discovery, though, this is going to give him a crucial new power. The ability to act like a traffic cop on this new energy path. While he's out chipping away at rocks, Grok finds this really shiny, heavy, metallic crystal. We know it today as galena. And he notices something totally bizarre about it. When he puts it in his copper loop, the energy flows right through it one way. But if he flips the crystal around, the flow stops dead. It's a one-way gate. What Grok found is what we call a diode. And get this. The early radio pioneers back in the 1900s, they used this exact same crystal with a little wire called a cat's whisker to build the very first crystal radios. It's just an electronic one-way valve, and it's totally fundamental for controlling current. Okay, so Grok has a path for his energy, and he's got a one-way gate. But the real magic, the secret sauce of all electronics, happens when he starts playing with the most common thing on the planet. Sand, or as we call its main ingredient, silicon. And this is where things get really, really interesting. So in his fire pit, Grok notices that when he heats sand to ridiculously high temperatures, along with powders he's crushed from other weird-looking minerals, the glassy rocks he makes afterwards behave strangely. Some of these new rocks conduct energy just a little bit, while others almost seem to want to suck energy into them. He doesn't know it, but he's just discovered doping. You see, pure silicon is what we call a semiconductor. It's not a great conductor like his copper, and it's not a great insulator like wood. It lives in this weird middle ground, and its superpower is that by adding tiny, tiny amounts of other stuff, those impurities in the doping process, we can precisely change how well it conducts electricity. So our guy Grok develops a kind of recipe. By tossing in certain minerals, things that contain what we call arsenic or phosphorus, he creates a rock with extra energy carriers. We call that N-type silicon. Then by adding others, like boron, he creates a rock that has a shortage of carriers. We call that P-type. He now has two very distinct, very magical types of rock. This is the moment. This is the big breakthrough. Grok has his conductive loop, he has his one-way gate, and now he has his two special kinds of cooked sand. He is about to put them all together to solve his problem and invent something that will literally change the world, or, at least his world. He takes his special rocks and he makes a sandwich. It's that simple. He puts a thin little slice of his P-type rock right in between two pieces of his N-type rock. Without a clue what he's done, he's just created an NPN junction, and that is the basic structure of a modern bipolar junction transistor. Grok hooks his little rock sandwich into his copper loop. Using some kind of primitive microphone, maybe it's a vibrating animal bladder, who knows, he leans in and he whispers into it. That tiny little bit of energy from his whisper goes into the middle layer of the sandwich, and it controls a much, much larger flow of energy that's going through the outer layers. The result? A mighty roar comes out. His whisper has been amplified. He can finally warn the clan. William Shockley, one of the actual inventors of the transistor, had this perfect, if slightly unhinged analogy for this. The tiny bit of energy it takes to strike a match, that's Grok's whisper, causes the massive, chaotic energy release of a kicking mule, that's the amplified roar. A tiny little input signal controlling a huge output, that's amplification. And that is exactly what Grok invented, a transistor. It's a tiny device made from a semiconductor that can take a small, weak signal and boost it into a much larger, more powerful one. It is the absolute foundation of every single electronic device we use today. Now, Grok's story is, of course, a fantasy, but it does show how the fundamental principles of our most advanced technology are really just rooted in the basic materials and physics of the world that's always been around us. And those diagrams Grok scratched on his cave wall, well, you could say they were the world's very first schematic diagrams. The visual language of lines and symbols we use today to design these unbelievably complex circuits, it's really just a direct descendant of that first simple thought. I need to draw a map of how the energy flows. So the takeaway here is pretty amazing. The silicone in the sand, the copper in the rocks, the laws of physics that make it all work, they've been here for millions and millions of years, just waiting for a curious mind to come along and ask, hey, what if? It really makes you wonder, doesn't it? What revolutionary building blocks are we all walking right past today, just waiting to be discovered?